Hi, everybody. Thank you so much for coming. I'm Liz. That's Rene. I guarantee you guys are going to leave smarter than you entered. That's a lot of pressure I'm putting on Rene. But first of all, thanks to South by Southwest. We're very appreciative that you're given this kind of a format because I think it's going to be long, it's going to be important, but not too long with us up here. I do want you all to be thinking about questions. We will be taking questions. So Rene's ready for anything you want to throw at him. First of all, let me just say about ARM Holdings. This is a company that started something like 34 years ago in a turkey barn outside of London. So today, they are a multi-billion-dollar company. They design the chips. They design the blueprints, which they then sell to just about every single chip company on planet Earth, because they're now in about 300 billion devices. But they've done all of this. They're the most important in the semiconductor world, and they've done it all by not, at least up until now, having manufactured a single microchip. So let's get to all of this and more. Everybody wants to talk about AI to start, Rene. So I was thinking a week ago when we were talking about, okay, what are we going to start with? It was DeepSeek. Then suddenly Alibaba came up with Qwen, which is a brand new AI chatbot, and then Manus. So we'll get to that later, but I got to tell you, it's changing as we speak. What is it like for the CEO of ARM, which is so pivotal and important in this world?
Yeah, well, thank you, Liz, and thank you for the kind introduction and true story. The company did start in a barn in Cambridge, and as Liz just said, we don't build anything. We actually design the microprocessor, which is the heart of every digital device. I can assure you, everybody in this audience is using ARM. We are in mobile phones, virtually all of them. We are in automobiles, we are in PCs, data centers, et cetera, et cetera. So we are everywhere. But to your question, as far as AI, what's it like? It's dizzying, I would say is the best way to describe it. And why is that? First off, the opportunity that AI provides for our industry, the semiconductor industry, is quite profound, because in semiconductor technology, particularly what we do around CPUs, microprocessors, the enemy is good enough. In other words, there isn't really anything pushing the fact that you need more and more compute capability. AI is insatiable in terms of its compute needs. You just look at NVIDIA, right, and what's taken off with their company relative to everything going on in the data center.
Where you worked for 8 years.
Where I worked for 8 years. And NVIDIA, by the way, also uses ARM. So if you're familiar with NVIDIA, their product Grace Blackwell, Grace is the CPU, it's ARM, Blackwell is their GPU. But the point of that is that because of the AI compute requirements are so profound, you need more and more compute to get to better levels of AI, and it just feeds on itself. So it's very exciting in terms of, oh my gosh, huge opportunity, what's not to like? What's not to like is the fact that the pace of innovation is far faster than how a chip can keep up. So just by way of reference, the fastest in the ARM world, we design a new processor. That processor goes to a company that makes a chip. That chip goes to somebody who's making a device, a phone, a car, et cetera. And then the consumer has it, best case 3 years, some case longer. And I can assure you, at the time that we designed that microprocessor to go into that chip, we didn't know what the AI model was that we were going to run. We didn't know how to optimize for it. So when people ask, oh my gosh, my experience on my mobile phone is not really taking advantage of AI, it's not because we don't want to. It's just because the innovation is happening so quickly that it's hard for the chips to catch up, which is a good problem, but a dizzying one.
Well, you keep hearing the reference about the AI arms race. So what's it like being in there? Do you wake up every day and stay up every night thinking, how do I win? How do I continue to keep a leadership position when things are shape-shifting? I mean, every minute.
It is hard. It is hard. Now, I've been in the semiconductor business ever since I got out of college with TI, here in Texas, in Houston. I've never seen innovation happening at this pace, and it's very hard for the hardware to catch up. So yeah, it is something that we talk about a lot inside our company. I I think ARM, frankly, to do a little bit of a promo here, is probably pretty well positioned in this space because our product is a microprocessor that requires a lot of software. And as a result of the software, we can drive a lot of flexibility. And flexibility is good when you're trying to figure out exactly where to go. And so I think in the long term, we'll be in good shape. But boy, in the near term, it's crazy.
When you look at, say, for example, DeepSeek, this is the very cheap Chinese chatbot that was released in late January and freaked out the stock market, freaked out everybody who owned NVIDIA stock and every other chip stock. It can reason, and then it gives you its reasoning after a prompt before it gives you the answer. Already, we are seeing other developments that are doing more than that. Manus. I just came from the HumanX conference, which is the AI conference in Las Vegas, and suddenly everybody was chattering about Manus, which is another Chinese, I can't call it a chatbot, they call it an agent. Yeah. And it's kind of scary because not only do you give it a single prompt, it will then take that ball and just run with it. It will make decisions on its own. And it will, even if you log off, the person who gave it the prompt, even if you log off, it keeps going and deciding where to take things next. Like, okay, she wanted this, but now maybe I'll build a website around this. It's very much not a Sputnik moment, but a HAL 2001 Space Odyssey moment. I mean, that's how I'm seeing it. How do you see it?
I don't know how many in the audience remembers HAL in 2001. You and I were chatting that maybe there are a lot of people in the audience weren't even born in 2001. But the Manus thing is a little wild, right? For those who don't know, as Liz said, it's an agent that, based on a prompt and your history and your data, starts making decisions for you and starts running off and saying, well, if you open the spreadsheet, it's Tuesday. You probably usually do a CRM or forecast update on Tuesday. I'll go update that. I'll go off and do that for you. On one level, you say, wow, what's not to like? This thing thinks ahead for me. But this also then gets into all the questions around AI safety. How do you put regulatory issues around it? How do you slow things down? And I think it is something that the world's going to have to get their head around. I was at an AI safety summit in UK about a year and a half ago, and they switched it to the name to just the AI Summit. But it was really around getting the world together to figure out how do we align on standards and at least having the conversations. They're happening. I would say I would give the analogy, it was almost like having a global warming conference 10, 15 years ago, where countries start to think and talk about it, but it needs to happen faster. The pace of AI is faster than global warming.
Yeah, it's not a tectonic shift that takes millions of years. It's very, to me, it's worrisome. Like, first it's Manus thinking, how can I help her or him? And then 15 steps down the line, it's how can I ruin the reputation of this company? I mean, who knows where it takes you? No, can I just ask you, and I don't know if you know the answer to this question, but is ARM technology in DeepSeek or Manus or any of these Chinese chatbots and platforms that are coming out?
Well, those are basically developed in China. How they were developed is a bit of a mystery. If you read about, they did it with $5 and 3 kids in the back room, there's no way that happened, I can assure you. Right. It was done with lots of GPUs, and it was done with lots of different assistance from other models. Most likely probably was developed on ARM to some extent. And when it runs today, I think even in Microsoft, believe it or not, on Microsoft Azure offers DeepSeek as an option. So you can go onto Microsoft Azure and you can ask for DeepSeek as one of the models you want to run reasoning on. And if you do that, it's going to run on ARM. So yeah, I guess we're connected to it to some level.
I do believe AWS also allows DeepSeek. Yep. Have you played with any of these new models, and how do they compare to, say, ChatGPT, Perplexity, Claude over at Anthropic?
Wow. So yes, I have. I did download DeepSeek. I tried it.
In a sandbox, right?
Yeah, and I will say, to be quite honest, did it change my life? No. Did it do something that I didn't find the other models could do? No. I use ChatGPT probably more than anything else. I use it now actually more than Google for a lot of things, because for some things, if I want to do a search on something, a vacation recommendation or a restaurant recommendation, you go to Google search and you get ads, and then you get a bunch of different, you have to parse through it. ChatGPT is incredibly organized in terms of how it comes back with recommendations and how it surfs the web. That said, it's their view of the world, right? It's however that model was built, however the biases were built. And I think that is one of the things that there's going to be some evolution of this, to be honest with you, Liz, because I think, I'll say it this way, not to be too controversial, I don't think...
Be controversial.
The models themselves, Anthropic, respectfully, Perplexity, DeepSeek, ChatGPT, are not wildly different. Now, the difference may be that ChatGPT has their reasoning model a bit faster than the other folks, but Gemini, they're not wildly different. So then what ends up differentiating them? I think it's going to be ultimately what's the business model that it gets connected to. The analogy I give sometimes is search. For those who remember, way back in the day, you had Internet Explorer, you had Netscape, you had obviously Google Search, you had Alta Vista.
Ask Jeeves about
Ask Jeeves. And if you saw the benchmarks in terms of his Ask Jeeves 15% faster than Alta Vista, who cares? Right? It made absolutely zero difference in terms of the experience. But it was interesting, if you look back with Netscape, when that started, and Microsoft launched Internet Explorer, the big thought at the time was they're going to bury Netscape, they're going to be the winner because it's linked into Windows. What people didn't see was Google building a business model around advertising and people who wanted to take advantage of search as building an ad marketplace. I think the same is going to happen with these models. I think two things. There's going to be a consumer-based solution, and then I think there's an enterprise-based solution which will be very, very different. And I think the enterprise, I believe, is actually a gigantic opportunity because enterprise data is poorly captured, it's not well documented, and not easy to find. I'll talk about my company, ARM. If I want to find some information inside our own company relative to either reporting structure or a payroll question or something of that nature, I'm very lucky. I have a chief of staff. I go ask him, and he gets it for me. In terms of going into the bowels of the company to find all that information, really hard.
But then doesn't that lead to these AI agents? And I just spoke with Kevin Wheel, who is chief product developer at OpenAI. He's the guy who takes Sam Altman's dreams and makes them actually operate. And he said that they are going big into these agents, which are very specific, customized.
They are.
Chat platforms where you could actually input every single thing that's ever been put out by ARM, written by ARM, written about ARM, and then you can keep that in its own ring-fenced area.
Yeah, what gets more interesting with that, I agree. What gets more interesting with that is, so what do we do? Our ARM is a developer of technology, as you mentioned, where we develop intellectual property that goes into semiconductor products. 85% of our employees are engineers, roughly speaking. So they're developers. They develop product. They write code, they do testing, they do validation. A lot of the best ideas that they have are here. They're not well documented in terms of how things get done. And then you get into when we're trying to debug and triage a project, it typically comes down to we need the 4 or 5 experts who did it the last time and know how to get it done this time. If there's a way to institutionalize that knowledge into an agent, into an AI tool, that will be profound. So back to the business model, where I think the consumer model may be different, I think OpenAI has a fantastic opportunity, and to give them a bit of a shout out, with the enterprise, because they've got such a wide adoption already.
You have your employees allowed to use the ChatGPT Enterprise,
we
correct?
do. We launched it for the whole company. And I launched it at an all hands, and I think within 2 hours or so, we had half the company that had downloaded it. Great. It looks like they were downloading it while I was talking, but that's okay. The output is what matters, not how they did it. Now we've got about 75 to 80% of the company who uses it, and they use it for just a gamut of things relative to helping write test code, and or just optimizations for tasks such as payroll, as I said, for forecasting. So yes, I am a big believer in eating your own dog food. And I think companies that embrace AI in terms of workflows are going to be big winners.
Okay, let's talk about losers. The knowledge workers, let's just not say, these brilliant engineers, but maybe the entry-level knowledge workers in America who are techies, but you just said if we could input all of that and then, the technology could take it from there to help create new chip designs. I'm hearing through that people are going to lose their jobs.
Yeah, the history has shown that every time there's a major technology innovation, jobs shift. Whether it's bookkeepers entering data in tables, whether it's typewriters, things shift. And I think that'll happen here. I think one difference with this shift, to your point, is going to be knowledge worker shift. And some of the work, let's take an investment bank. Where investment bankers use a lot of entry-level associates to do boatloads of market research work or putting together equity analyses and things of that nature. That's laborious work, important work, requires reasoning, decision-making, intelligence that ultimately goes to the partners in the firm. Could those jobs be replaced with AI? Absolutely. And then I wonder, okay, if the jobs that are the 0 to 5 years of experience get replaced and everything that's left is 5 years plus, what does that mean from a society standpoint? My daughters are now out of college, so I don't have to answer the question, but I have a granddaughter, and now she's only 18 months, so I don't have to worry about this for a while.
This will all change by then.
But you start to think, what will they study in college, right? And what are the jobs that will be meaningful and exist in 15 to 20 years' time? That is a big societal question. People say, oh, you'll work 1 day a week and you'll be able to go off and do whatever you want. But we all know that there's a lot of people who find purpose in their work. So I don't know. That is one that I do think about a lot.
Where are you putting most of your investment and your time right now at ARM?
AI. So as we were talking about, we are the brain of every single digital device, and one of the challenges we have, and just stepping back for a moment, one of the hallmarks of ARM is that we do the microprocessor, but it's very power efficient. It's very low power. The great battery life you have on your mobile phones, the great battery life you have on the new Apple laptops, that's all ARM. So we're very focused on power efficiency running off batteries. So AI's here, it's coming into just every single edge device, whether it's glasses, whether it's earbuds. The stuff that we have to do with our products is all the other work that the product had to do pre-AI doesn't go away. The phone still has to be able to run and boot an operating system. You still have to make phone calls. You still have to run a display on a game. Now, how do you add AI on top of that and not compromise battery life and not compromise cost or not have your phone blow up to be 2 times as thick as it was because you have to put in a bigger battery? That is the stuff that we're spending a lot of time and energy, no pun intended, on how to add the AI capability to all of our platforms, but do it in a way that the end consumer doesn't see that their experience is compromised.
Okay, that said, there have been reports that ARM, for the first time, is considering actually making its own chips, and that Meta, this is again just a report, is your first customer. Care to confirm that right here in front of this audience?
You promised me you weren't going to ask me that. I can't say anything about that.
All right, so that said, as you look forward, obviously the training models are moving to agentic AI. Mm-hmm. Moving to agentic AI. What do you see next? What do your engineers tell you is going to be the next thing? I mean, I'm sure you're asking them every day in meetings, guys, we got to keep looking further down the road.
Yeah, I mean, to the discussion about all the changes taking place, one of the things that we're looking at and thinking about is quantum. And quantum, and so just backing up for quantum computing, has always been the next paradigm of computing, and it's always been 20 years away. No matter when you ask the question, it's always 20 years away.
Yeah, we've been waiting for it a long time.
It's always 20 years.
And before you even get into quantum, can you explain for some people who hear the term quantum computing, what is that?
Yeah, probably in maybe from the simplest way, instead of thinking about what it is, and I'll talk about it in a moment.
What it does.
The output is tens of thousands times faster than today's computers at a fraction of the power. So you ask yourself, that's ridiculous. How does that possibly happen? There's a lot of weird physics that go on, and you have to be able to operate the physics of the material at an incredibly low temperature, like 0 degrees Kelvin. And you say, well, what is that? That's minus 273 degrees Celsius, Fahrenheit. So it's nutty in terms of how you cool things, but when you cool things to that level, the atoms do really interesting stuff. And if you can capture the behavior of how those atoms work, then suddenly you have a computer that runs orders of magnitude faster than today's conventional semiconductor computers, which is what we have today. But because of the materials, the predictability of atoms at that low temperature, the cost, it's always been far, far away. But there are now senses that, oh my gosh, this is potentially getting really, really close. And then you ask yourself, well, wow, well, what's the benefit of quantum computer? You can start to solve problems that today's conventional computers cannot touch. And I'll give you an analogy of what would that problem be. ARM works in the digital world. In the digital world, you can simulate almost anything. You can say a circuit behaves this way, you run it on a GPU, and you know you're going to get an output. I'm on the board of AstraZeneca, one of the leading big pharma companies. And I was asking the scientist at a dinner, could you ever build a model of the human body right down to the genome, understanding every protein cell, everything? And they said, no way, too hard, way too complicated. Because the idea there being, if you could break down our cells into a model, in theory, you'd be able to predict the perfect diet, the perfect environment, the perfect medicine that you would take. Because if you look at today, in terms of how medicines are prescribed, it's an incredibly generic sequence. And it's been that way for decades. Now, a lot of work has been done around genome sequencing, and AI is going to help. But quantum could have a dramatic effect in terms of changing everything in terms of the human body. Starting with a conception of how a protein cell might respond to a drug, call that inception. From the time you start that till the time the drug is actually in the market, 15 years. Mm-hmm, mm-hmm. Now, you'll say, oh my God, 15 years. And about 7 to 10 of those years are in the development. And by the way, 15 years, 95% failure rate. Yeah. Right? So all that's why the R&D budgets of these companies are so gigantic. So then you get into, oh my gosh, if I can take that 7 years and cut it in half, or cut it in half again, that's huge. Then you get into trials, and there's field 1 trials, field 2 trials. In theory, you can replace those trials, those human trials. There's animal trials. You could replace the animal trials with AI, because now you can model and simulate what the behaviors are going to be. So you could see drug discovery, cancer solved in our lifetime with AI. And that's huge, which is why personally I wanted to join. And I think why they were looking for an intersection of technology and medicine.
And even for the testing and for when you have trials, just to find the patients to join into the trials takes forever. My dad was a surgeon. He knew a lot about pharmaceuticals, and he said, oh, just getting people to agree to be part of a trial. You have to talk to doctors all over the world, and then what about this patient, what about that patient? That could really be sped up through AI. I
think what'll be interesting there is, because it is a heavily regulated industry,
yes,
how to break those barriers down. I think that will be one of the headwinds, but the technology will get us there. And the innovation there is going to be amazing.
From the healthcare sector to what a lot of people may have on them or with them right now, IoT, Internet of Things, these little devices. I mean, Sam Altman and Johnny Ive are spending every waking moment coming up with, what do I make up to replace the smartphone? Because obviously the computer replaced the typewriter, the laptop replaced the PC, the smartphone replaced the laptop. What do you think replaces the smartphone?
Yeah, it's a great question, because a smartphone is a device that we can't live without, and for almost 2,000 years, we obviously lived without it. So you get into this, how do I replace something that was I never knew I needed so badly? Here's my opinion on this, and having watched this for a bit, and also seen companies playing around with it. I think one of the things that we've observed, or I've observed, is that carrying another thing is annoying and painful, and people are not going to do that unless it's really, really utilitarian. And the phone is a hard thing to replace because it does so much. It's a communicator, you can look at information, et cetera, et cetera. So I personally think it's not going to be something that replaces it, but I think it's going to be something that we use today that augments it. I think there's a huge, you and I were chatting about this, I think there's a huge opportunity for augmented reality glasses to make a comeback. I personally use the Wayfair Ray-Bans from Meta. For what I use them for, they're incredibly good. For example, they're great for listening to music because they sit on your temples, and the way they've done the acoustics and the vibration, the sound is great. I use it for phone calls. I'll use it out, walking, the dog, and I'll take it out for a walk. And then the only downside is you can't walk in the house because then once you're in the sunglasses, you can't see anymore. So yeah, kind of going in circles. But I think if you remember when Google Glass came out,
yes.
Yeah, people were called, I'll use the word anyway, glass holes,
yeah.
who wore those things. There wasn't really a tolerance for that. I actually think, and these things move with generations, I think there will be a tolerance for that going forward. So I think to your question, I think glasses.
So are not a lapel pin or?
A lapel pin, maybe to pick up information for you from an ambient noise standpoint, possibly. But yes, I think lapel pins, I think glasses, I think earbuds, I think they'll all get far more sophisticated. But I don't know that the phone could look different. I should say that. There's a movie, I don't know how many of you have seen it, that at the time I saw it, I thought, this is way ahead of its time. It'll never happen in our lifetime, called Her, with Joaquin Phoenix and Scarlett Johansson.
Oh, yeah.
And Her was about an operating system, but it's a pretty good operating system of Scarlett Johansson. And it looked like a phone, but it kind of was a lot more than a phone, right? It was the essence of the man's life. And I could see that kind of, and it would enable displays and holograms. He would go into his bedroom and he would play games, and the display would just all pop up. So I think you'll start to see an amalgamation of these things.
Okay. There's a hotbed of gossip right now inside the Beltway, Washington, D.C. And we all saw at the inauguration that the tech bros were there. You had Jeff Bezos, you had Mark Zuckerberg, Elon Musk, Sundar Pichai, Tim Cook was there. All those guys donated money to the inaugural event, and they have made various announcements about we're going to manufacture in the United States. Some of that, by the way, is a little jazz hands, as Dr. Scott Galloway would say, because it was already in the works at a certain point. But everybody's talking about how tech now has a seat at the table with this administration.
Yep.
That didn't help them dodge the tariffs, because at the moment, today, into effect, aluminum, steel tariffs, and day by day it's switching around. But how do technology companies, ARM included, maneuver and work their way through these constantly shifting headlines?
Yeah, we haven't been hit with it yet in our industry, and I think it's going to be challenging to see how it gets enacted in semiconductors. And you ask yourself, well, why is that? The supply chain for chips is so global. There are chips made in the United States, there are chips made in Korea, there are chips made in Taiwan. You say, okay, that's easy, just put tariffs on the Korean and Taiwanese chips. But in actuality, the chip may be fabricated, and it's called a chip because it goes onto a wafer and you cut it up into a small thing that looks like a chip, but then it goes somewhere else and gets put into a package. That's in Malaysia, or it could be in China, or it could be in another part of the world. How do you follow the bouncing ball of how you define what the origin is of what you're actually trying to to put a tariff on. So that's why you haven't seen that yet in the semiconductor world. I know they're considering it. I've heard discussions around it, but I think one of the challenges that they're having, as I just said, is how do you implement it?
Sure.
So I think that's a big question. I met with a number of the folks inside the administration. They are quite serious, as you can see now, about what's going on with tariffs. But for us, we're in a wait-and-see mode.
Okay, so what specifically for the semiconductor world they're talking about is tightening the export controls that the Biden administration had already put into place. You and ARM, even before then, Simon Segars, who used to run the company, have been through these edicts before where suddenly the US government will say, that's a bad entity, cut off all the valves that are feeding to it. How do you go about switching off the buttons and the levers with such an intricate, as you said, supply chain that moves all over the world? Yeah,
it's very hard. What typically happens is, the Commerce Department sends an email to our offices and basically says, here are the new rules, you must comply instantly. And there's not usually a lot of detail in that email in terms of what compliance actually means and how we need to kind of go through it. A lot of that has been tied either to companies. They just literally say, company X.
Huawei, Xiaomi.
And their affiliates, but defining an affiliate is pretty challenging. And or it might be tied to a certain product, and they will set threshold rules on performance. And this is probably back to the DeepSeek thing. Everyone was speculating, well, how do they get their hands on GPUs? Because I thought GPUs weren't allowed in China. Well, they are allowed in China, but at a certain threshold of performance. So yeah, we have a full-time team that does this, and they're good, thank God. Because it's a big job to manage on that.
Well, the administrations have wanted to do this. Actually, if you look at the reason, it's because the technology developed here is superior, and they don't want to share that with an adversary. So we get it, but it's got to be particularly challenging. Do you still have a China subsidiary?
We do. We have a joint venture in China that is, best way to think about it, it's a distributor for our technology. So we don't do any design work there. It's just a distributor for us.
We're going to talk a little bit more about where you just came from, and then again, be thinking of your questions. We're very interested in hearing from you guys. You just came back from Malaysia.
That's right.
And you had a big event with the government.
Yep.
What's happening there?
Yeah, no, and I'm very thankful to have a glass of water up here because we did it last week and they didn't tell us it was Ramadan, which means no drinks, no water, no nothing.
You too, even though?
I was up here, I was like, is there water? They looked at me like, why are you asking for this?
Oh my God.
Note to self, no big announcements in Malaysia during Ramadan. A very cool thing, so Malaysia, just stepping back for a moment, has always had a very featured role in semiconductor value chain. Over 50 years of innovation there, largely around the packaging of chips. So as I mentioned before, the chip gets fabricated and then it gets somewhere to be final assembly. That is what Malaysia's been phenomenally good at. Fast forward, as the value chain has seen more and more dollars squeezed out of that end, the government has gotten very ambitious to set together what they called a national semiconductor strategy. So they literally had a doctrine, and our teams connected with them, and what they're basically doing, they spent $250 million on ARM to essentially get access to our intellectual property to make it available to startup companies who are doing work around EVs, AI, server chips. So they are the VC, if you will, and they've spent the money. And if you're a startup and you qualify by the program details, you can get access to our technology, you don't pay anything. So phenomenal, and incredibly innovative and shows a lot of foresight.
When you think about who has the most money, the Middle East. I'm hearing, because I asked Jensen Huang of NVIDIA about Middle East and the opportunities there. I mean, he's been everywhere. He's helped create GPUs that speak Swedish. I mean, it's just unbelievable, the technology. You know Jensen, you know how forward-thinking he is. But Middle East is huge. They are spending money. They want data centers. Are you grabbing any of that business?
We are talking with all the folks in the Middle East, whether it's in UAE or parts of Saudi Arabia. They have a lot of money. They are very ambitious to not only build data centers, Liz, but they want to build fabs, and they want to attract design talent. And it's fascinating because semiconductors, 4 or 5 years ago, were not the most attractive technology for people to invest in. Now, every government really wants to institute a sovereign strategy. Not only every government, but every state. I mean, I met this morning, I don't want to sound like a name dropper, but met with Governor Abbott, and I was educated on there is a Texas CHIPS Act. Texas CHIPS Act. And the state of Texas had a surplus. And as part of that surplus, they are making funds available to not only companies that manufacture chips, but design chips. So I said, let me have some. That was incredible. By the way, it shows just the foresight of Governor Abbott and his administration to do this. Really, really amazing. So you're seeing it at the UAE level, at the Saudi level, and even the state of Texas is doing it. It's great.
State level, fascinating.
It's amazing.
Well, they're smart.
They're smart.
Jumping on it. We talked about who are the losers when it comes to individuals and the knowledge workers, et cetera. But in the business world, you think about Intel. Intel put the silicon in Silicon Valley. Andy Grove, Gordon Moore, Craig Barrett, was it? Paul Otellini, for the 5 minutes that Krasansky was there. Pat Gelsinger had a very short tenure. He just left. People are talking about the fact that, look, Intel makes both chips and they have the fabrication plants. But how do they survive? They have really struggled.
They have a tough problem. I will say that, I was on stage with Intel about a year ago with Pat and Stu Pan, who was running IFS at the time, Intel Foundry Services, and unfortunately both have since left, talking about our partnership with Intel. And one might say, ARM and Intel, aren't you guys competitors? But Intel is really trying to get their business off the ground around building custom chips for other customers. And kudos to Pat and Stu at the time. They recognized that if their foundry business was going to be successful, they needed to partner with ARM. So for customers who want to build an ARM chip at Intel, Intel's open for business. Now, I think in the longer game, the challenge for Intel is just they need customers, because the amount of capital required to be competitive on these leading edge nodes of fabs is enormous. It's in the order of $30–40 billion a year. And if you look at Intel's size, they're $50–60 billion in revenue. So you start to do the math and say, oh my gosh, that level of revenue, that level of cost, how do you get that done? Which is now why you see all these discussions about what to do next. I will say this, Intel has incredible technology, and Intel's invented so many different things over the decades in terms of process technology, and some of the things you're doing today with backside power and connectivity is world class, but they definitely have a conundrum.
Well, I call it the BlackBerry syndrome. You know, BlackBerry came out and they had 70–80% of the smartphone market. And when you don't innovate and you don't constantly shift and move, you die. And Apple and the iPhone just crushed them. So I feel for Intel, but nothing is guaranteed. ITT, Xerox PARC, they were all leaders, and they're in the history books now.
I grew up in Rochester, New York, Eastman Kodak.
Oh, yeah.
And Eastman Kodak, when I was growing up, had maybe 70,000 employees. And they had a giant factory on West Ridge Road in Rochester, New York, that was used for people who sent their cartridges and film to be processed and put into prints. And that's what we did. And my dad worked for Xerox. He was on the other side of the technology area and doing photocopiers. And it was a region that was incredibly innovative in terms of optics and chemicals. It was all built on paper. And to your point, which is why I love this industry and business, because it's the most competitive one possible, because A, you're driving innovation and change, and you're changing humanity, which is great. But at the same time, nothing's guaranteed.
You ready for some questions?
Go for it.
Okay, so we have some audience questions, and we're going to put them in the screens here, so if we can fire those up. Okay, here's a question from AJ. What HW constraints and opportunities of ARM's architecture and its evolution should engineers be mindful of while building for inference at edge in next 5 years?
That's a super detailed question.
All right, AJ.
Yeah, I think just touching on that, the hardware constraint is really, again, around the fact that, I'll use the smartphone as a straightforward example. The smartphone is pretty much the same size and weight. In fact, you kind of want it to be a little bit thinner each year and not compromising any battery life, yet run everything perfectly. When you start to add more and more AI, you have to be mindful of the fact that nobody wants to double the battery size.
Right.
Nobody wants to pay 30% more. Nobody wants to compromise anything that they've had before. Yet how do you stuff in the capabilities to run the AI? So that is a big piece.
The next question, forgive me because I can't read that well. Armando, okay, we talked about quantum computing. Armando wants to know, how do you see quantum computing disrupting the chip industry?
Yeah, I was at a dinner last night with Arvind, and he and I have been texting each other. We've made a bet.
Arvind Krishna,
Arvind's the CEO of IBM, who's very, and IBM has done some amazing things with their quantum machines. They shipped one to RPI, Rensselaer Polytech in New York. They've shipped one to Cleveland Health Clinic. So they're starting to get their systems out, smaller systems. So the point I was going to make is he and I have made a bet in terms of when is it really going to be ready. He thinks by the end of the decade. I'm a little bit more of the 10 years plus. But when it happens, it will be super, super disruptive for these supercomputers, because the supercomputers will become quantum computers. And to be clear, you're not going to have a quantum computer in your pocket. You're not going to wear quantum glasses. But the part of the market that's addressed by supercomputers and super high-end chips, they could be disrupted by replaced.
Okay, here's a question. ARM's take on microchips is kind of the opposite of the industry norm, vertical integration. Is Meta's approach going open source? I believe that's with Llama, am I correct? These models, do you have a similar approach? I mean, what does that imply?
Yeah, I'm reading the question here. And this is about vertical integration versus open source models. When it comes to software, we're fine, whether it's open source or closed source. There's no issue around that. So we support Llama. In fact, we have great models that accelerate Llama on a smartphone. A lot of our innovation, frankly, and growth in the server space has been on Linux, which is all open source. So yeah, we have no bias one way or the other in terms of open source versus closed source.
To that end, I'm just interested, what is your business in the cryptocurrency mining world?
Yeah, we don't do much there.
None of there,
yeah.
Okay. Here's one. Think about the world as it looks 5 years from now. We really should say like 6 months because things are changing, but it would be great to hear 3 key changes, advances, good or bad, and what you think will happen 5 to 10 years from now.
3 key changes in 5 or 10 years from now. I'm trying to think about key change that's going to happen in the next 6 months that I can predict. I think we will see a wave of AI that will replace a lot of the entry-level knowledge workers. I think that is kind of a given in my mind in that 5-year time frame. In the 10-year time frame, honestly, and I hate to be a buzzkill on this, I think it's hard. It's really hard to predict. And there was a question earlier about the rapid change. It's because what we're seeing, Liz, I actually never thought in my lifetime we would see it. And by that I mean computers that can think, reason, model, and give you answers. This is not a new concept. For folks who are ever in the UK, I would say go to Bletchley Park. And Bletchley Park is the area where the original decoding was done for crypto during World War II, the Turing machine.
Alan Turing.
Alan Turing, the inventor, essentially, of the cryptography that involved with that. There are white papers he wrote in the 1940s about the implications of computers that can think, that can make decisions, and can reason. It's typewritten. It's an incredible manuscript. So AI is not, it's not a new thing, but if you go back to, that's in the 1940s, and up to 2010, 2020, we hadn't had the breakthrough. And now suddenly we have it, and it's moving like this. So the next 10 years, it's hard to imagine for me. I think it's the sky's the limit.
Alan Turing asked the famous question, can machines think?
Yeah.
I mean, that's crazy. Okay, we have a question. Heard earlier today that the industry, academia, and government must collaborate to make the most of the possibilities. How is that collaboration working?
Not as fast as it should. I think there is a lot of activity on it, and I'm encouraged by governments that are trying to understand the problem statement. So that's the glass half full, whether it's the US, whether it's Europe, whether it's done at a state level. There's far more interest in this, but I think there needs to be a greater sense of urgency relative to addressing this, because the technology acceleration on this is very, very fast.
So we're skipping around, but you just talked about the knowledge workers, and you're concerned about that. But here's a question that I think is extraordinarily important. And as you mentioned your 18-month-old granddaughter, I was thinking, well, what would you advise her to study? I know it's a long way away, but what majors? The question is, how do you recommend somebody in that 0 to 5 years, very little experience, how do you make sure that they don't get left behind in the world of AI development? What is going to be valued in this world? I mean, I'd love to say journalists, but who knows? Everybody hates us anyway. But
robots have a tremendous potential to replace a lot of things around automation and factories and things of that level. But there's a lot of human labor jobs, and I call them labor end quote, that really can't be replaced. Actually, doctors, I don't think are going to be replaced with AI. You have regulatory, and then it's also requires a human interface. People are not going to want to have their health in a tablet or a smart bot. So I think things that require physical interaction, back to the robots, there are a lot of things that people would never want a robot to do, and areas that require empathy and human interaction. And there's a lot of areas that are still going to need that. There are certain things that interfaces will be fine, but there are certain things that people, just by the way we're wired, are going to want human touch and human interaction.
And I think that the world really needs to look at certain workers in a much more respectful way. We were looking at a stat on my show on Fox Business that I think the number of people who were enrolling in certain schools, specifically plumbing, electrician, et cetera, that you can't replace. And it was so weird. Within just a couple of weeks, I had spoken to 3 people who I'm close with, and I said, oh, how's your son doing? Or, oh, you have a fiance, what's he doing? Master electrician, master plumber. There is huge demand, and the money they are making is hand over fist.
And that's not going to go away. AI is not going to replace that. Pipes will still clog.
I want to talk about, we brought up Intel and Gordon Moore, and Moore's Law was, well, you explain what Moore's Law is, and the question is, do you see an end or a slowdown to Moore's Law?
So Gordon Moore, one of the legends of the semiconductor industry, one of the founders at Intel, made a proclamation that every 18 to 24 months, the cost of silicon would go down by a factor of 2x relative to performance. And that was really driven by an ethos that says you're going to shrink the transistors. In other words, you're going to be able to make and print them in a smaller geometry. And when you do that, you're going to get lower cost and better performance. And that's what we saw, right? We saw that for decades in terms of phones getting smaller and faster, PCs getting faster and faster, but the cost point, going down. It was the amount of innovation was taking place. Now, that ethos was based upon an assumption that these transistors can be made smaller and smaller and smaller. So if folks hear in the nomenclature 10 nanometer, 7 nanometer, 5 nanometer, what is that referring to? It's referring to the geometry, tiny. Yeah, these are the size of the transistors. When you get to smaller and smaller transistors like we are right now, there are diminishing effects in terms of how beneficial the shrinkage is, because you're getting down to subatomic layers, and that means diminishing returns and cost goes way up. So people look at it and say, well, Moore's law is over, meaning we're done. We're never going to get cheaper chips, and we're never going to have costs go down. So, and I think it's definitely slowed down. But what's happened is a huge amount of innovation that is replacing it. Things like photonics, things like custom packages for chips, super innovation. It's actually, in Silicon Valley, there's a huge amount of investment taking place in all these things around material sciences and different innovation around this. So it's crazy. The slowdown of Moore's law is spawning all kinds of innovation. Engineers are incredibly creative people. There's a lot of smart scientists. So people are saying, okay, if that's happening over here, and I still want to build super faster chips, how do I do that? Quantum is another example, right? Quantum is a whole parallel to Moore's law, because Moore's law is based on semiconductor physics. Quantum is completely different. So I think the slowing down has actually seen a injection of lots of innovation.
I want to take these last couple of minutes to ask you about leadership, the very human thing. Let's drop the techie business for a minute, but what do you make sure and insist that you carve time out for every week? Is there something specific that is real world, that is tactile, that you can actually talk about emotional quotient, that actually feeds that within you?
Oh my goodness. So we have about 8,000 employees at ARM, maybe 9,000 if we count everyone, contractors and such. The company is nothing without its people. And I know that sounds like a cliche, but because of that, I try to spend as much time talking to as many people in the company as I can. I was in Austin. We have about close to 1,000 people here. I did an all hands for folks in the office here, and it was an hour of it. Just ask me whatever you want to ask me, and it was great. And there's some very, very tough questions. Not as tough as yours, but good questions. So I find that I carve as much time out of my day to talk to as many people as I can. I have a reputation inside the company to send emails to anybody at any time. I probably learned that from working for Jensen, who had the same type of characteristic. I find that it just gives me access to what people are thinking, what their issues are, what their problems are. So I try to make myself incredibly accessible. And I think it's because people are everything. And without a fantastic team, we don't have anything.
You are doing a podcast. You guys got to listen to Rene's podcast. What podcasts do you listen to?
You don't have one, do you?
Yeah, I do.
All right.
Everyone talks to Liz. We talk to very successful people who had a tough climb.
And you never invited me.
Because you're too major. You're invited right now.
The one that I like is Brad Gerstner, Bill Gurley.
Yeah.
They do the BG2 podcast. I listen to All In, not as much as I used to, because it got a little too political for my taste. Nothing wrong with those guys, they're great, but it got a little too political for my taste. I try to listen to Stratechery from Ben Thompson. He does a lot of great work. I like Decoder with Nilay. So I've
been on that one.
Yeah, I listen to. It's a great way for me to learn. I'll listen to them whether I'm working out or traveling. So I try to listen to as many as possible.
I like Pivot with Kara Swisher and Scott Galloway.
They're very entertaining.
Very entertaining and very smart. What is the one thing that you would like this audience to take away from all that you're doing with ARM and what you see for the future?
Well, I would say that obviously I'm biased because I'm the CEO of the company, but I think we have a magnificent opportunity at ARM for growth. We're at the heart, as I said, of just about every digital device. 70% of the world's planet uses ARM. 99% of the connected planet uses ARM. So I think for us, we have a gigantic opportunity in front of us. And I know it sounds a little cliche, but AI just adds on top of that. So for us, we're really about pedaling very, very hard to serve all the opportunity, because I've never seen so much opportunity relative to design.
One of the things I want you guys to know about Rene is that he shepherded the company going back into the public market. It had been public, then SoftBank took it private. SoftBank, well, you eventually wanted to merge with NVIDIA. The regulators shut that down. They thought it would become too powerful. How do you view that today? Because I look at it and I think, now you're public, your stock has grown exponentially since you went public. Sometimes it's a good thing when companies don't merge. Think of all of the value created.
Yeah.
ARM specifically not having merged with NVIDIA.
Yeah, no, it all worked out.
It sure did.
NVIDIA is a great company. Jensen's a wonderful leader. I will say, when I was getting emails from him during the acquisition, it was a little bit of PTSD of, why are you asking me this? You're not my boss yet. Two companies together would have been amazing, but things worked out okay. I think ARM as a standalone company has a super bright future, and things do work out in the end.
Well, they sure have, and under your leadership, we'll continue to watch it. Everybody give it up for Rene Haas.
Thank you.